Welcome to the Evolution 2.0 podcast, where we explore the intersection of art, technology, business, biology, and spirituality. Here you'll discover new trends in evolution that are changing the way we think about everything. This is your host, Perry Marshall, author of Evolution 2.0, 80/20 Sales and Marketing, and Guides to Ethernet, Google, and Facebook. I'm founder of the Evolution 2.0 Prize, a quest for the missing link between earth science, the information age, and life itself. Let's join the conversation now. I'm going to give you a really quick backstory on the Evolution 2.0 project. So like Greg said, I'm known as the guy that wrote the book on Google advertising and Facebook advertising. Those books are in their 6th and 4th editions respectively. And that's all nice and that's all fine and good, but there's not enough kamikaze pilot in that. So I have to busy my hands with other things. And so 20 years ago, my younger brother, Brian, graduated from seminary and he wanted to be a pastor, and he ended up, instead of being a pastor, ended up being a missionary in China. And a couple years into his missionary in China stint, he starts sending me all these emails because he's starting to have a lot of questions about, I don't know if all this stuff they told me in seminary makes sense. I don't even know if this Christianity thing makes sense. And we're both pastors' kids, and we're both in the deep end of like theological stuff. And so the emails start going back and forth, and so he's having a pretty serious tussle with intellectual issues. Well, I went to visit him in 2004, and when I got there, I figured out, he doesn't believe this stuff anymore. He is not on this train. And that was a little unsettling to me. And we were riding in this bus somewhere, and we got into this argument. I was feeling a little threatened by all of this, and I go, Brian, I'm an engineer, and I've built a lot of things, and this, the hand at the end of my arm, this is a nice piece of engineering. But you don't think this is an accumulation of random accidents, do you? And he goes, hold on! He just comes right back with it, and almost everybody's had this conversation. You don't need a designer. You just need millions of years of replication and random copying errors and natural selection, and you'll get a hand. That's an illusion, Perry. And I was like trying to think 10 chess moves ahead of him in the conversation, and I could already see, it might not make sense to an electrical engineer, but maybe the biologist knows something you don't. How about, instead of ruining your little vacation to China by arguing with Brian all the time, how about you just stop the arguing now, and when you get home, you go research this to your heart's content. And that's what I did. Well, I was kind of terrified because Brian, you haven't had a theological argument until you've had it with a guy with a master's degree in theology from a conservative seminary who knows Greek and Hebrew. Okay, that's like a whole nother ball game. So Brian was already rattling my cage, and now I'm diving into the vast realms of evolution, creation, intelligent design, and molecular biology. And boy, if you thought semiconductor materials or engineering fields and waves was complicated, try molecular biology. And so I was lost for a while. Well, then some things started to make sense. One day, I was trying to understand the genetic code, and all of a sudden I had this massive flash of recognition. Now keep in mind, I feel like I'm drowning. I'm terrified of where this is going to take me. Maybe this is going to make me an atheist. I don't know. My wife she knows what's going on. She's completely helpless to do anything or say anything to help matters any. I just felt like I was flying through a black void, And all of a sudden, it was like I grabbed onto a handle. And the handle was this. I wrote this book, Industrial Ethernet. The first edition was 2002. Now, if any of you have insomnia, this book will help. Now, I joke about that. In actuality, the ingenious way that they put ones and zeros on a wire and get it to go around the world is, if you can switch on your geek switch, it's actually quite fascinating. And if you're into this stuff, it's not insomnia. And it's incredibly clever. And it deals with some very, very fundamental principles of communication. And I'm studying the genetic code and how DNA works. And I'm like, I've seen this before. I know what this is. Oh my word. I know what all of this stuff is. And what's on the screen here, you don't have to really know anything to just see from the colors and the structure. This is the structure of an Ethernet packet, which all you people on Zoom, these Ethernet packets are getting unpacked and turned into pixels like a million times a second. Okay? This is DNA transcription and translation. So when a cell reads a strand of DNA and turns it into amino acids and proteins, it is mathematically the same as your computer taking an Ethernet packet and turning it into an image or a sound or a keystroke. It's the same. I'm like, oh my word. It's digital communication. DNA is digital code. At the most simplest level, it's identical. And it runs on all the same principles. Now this told me instantly that if evolution was true, it was not even remotely possible that it was random copying errors. Ask any IT guy if random copying errors help your router or your, ask them. They'll give you an emphatic no. Not possible, okay? What I found out was, so this all by itself might have turned me into a creationist or an intelligent design guy or an anti-evolution guy. But it didn't, because I discovered something else. And I'm just giving you like the really sped up version. I've been doing this for 16 years, so you're getting highly compressed. This woman, Barbara McClintock, this is a US postage stamp with her picture on it. In 1944, long time ago, she figured out that if she hit a corn plant with radiation which damaged its DNA, think like scrambling a hard drive, okay? The corn plant took apart those genes and chromosomes, reconstructed them, and recoded them so that they would work. In other words, the computer program rewrote its own code, repaired its own operating system in real time. This is 1944. This is before they even knew what DNA was. They could see it, but they didn't know what it was made out of. Everybody thought she was crazy woman. And in 1983, she won the Nobel Prize. The significance of her work is really, she was the first person to witness a live, real-time evolutionary event and figure out exactly what had happened. Remarkable. Especially considering the technology she had and the tools she had. It was incredible. Okay, now, this little story I'm telling you turns evolution completely upside down. Because I can guarantee that what 99% of you have heard about evolution It's random, it's purposeless, it's accidental, and survival of the fittest just sorts it all out in the end. That is not true. In fact, it's probably the biggest mistake in the history of science, and I am not exaggerating. The truth is, organisms are so like your body, or worms, or fish, or bacteria, or whatever, are so smart that when there's heat or cold or starvation or predators or whatever, they re-engineer their own genetics to adapt, and in many cases they will pass that adaptation on to their offspring. For example, here's a very practical example of this. I got a friend named John Forday. He is a pediatric children toxicologist who studies the effects of secondhand smoke on children. He says there are 300 effects of secondhand smoke on children. The number one worst effect is this. A woman smokes, her body, in reaction to the smoking, makes epigenetic changes which change her physiology so that she can deal with the smoke. Those changes get passed through her egg to her daughter, which get passed through the daughter's egg to the granddaughter, and the daughter will have asthma, and the granddaughter will have even worse asthma. And the grandmother could have died before the granddaughter was even conceived. So smoking causes hereditary diseases that get passed on through the egg to grandchildren. That is a real-time evolutionary adaptation. For 100 years, the evolutionary biologists insisted that was impossible. It's possible, and it's been happening for 3 billion years. And that's why evolution works, okay? And it's the best engineering anybody has ever seen, ever, okay? And anybody that tells you that science got rid of God, all they did was they kicked the can down the road to an even more difficult problem than what anybody was arguing about before. It would be like, you know, what if Tesla made a car that actually got better every year? Like, that updated its own software without connecting to headquarters. Okay, that's what we're dealing with. So, I was just astounded. It was like, why is anybody, everything I'm telling you, it's been in the literature for decades. Why is anybody telling you this? And this is standard literature. This is not like, I don't know, Aunt Josie's alternative medicine farm with llamas and painting, okay? Like, this is standard university research. Well, so this led me to do, I said, well, what are we going to do about this? So, long story short, I went out and started raising money for a technology prize. I said, you know that kicking the can down the road thing, back to the beginning? We got to put a spotlight on this beginning. Because whatever the first cell was, not only did it have digital code, it apparently had the ability to rewrite its own digital code. Nobody's paying enough attention to that. So I said, I want to put together a $10 million prize for anybody that can figure this out. You know who the first person I pitched was? It was Greg Hedges in 2012.
It was.
I roped him into it. I'm like, Greg, I get this idea. You want to meet with? And so I showed him this thing. Well, in 2019, I went to the Royal Society of Great Britain, which is the oldest scientific organization in the world. Isaac Newton was the president once. Charles Darwin was a member. Albert Einstein was a member. And I presented this prize with 2 Oxford professors. And so nobody's won it yet, but I think this is the most fundamental question in science that can be precisely defined. I also wrote this book called Evolution 2.0, Breaking the Deadlock Between Darwin and Design. This is the first book to correctly explain how evolution works at a level that a high school kid could actually understand. Because all that stuff that's been in the literature, part of the problem is it's so complicated, it's so difficult to explain that the stupid explanation usually wins out. And so, if you're interested in this subject, then you could pick up this book. Now, this is all just background.
Perry,
Yeah.
In one sentence, what is the prize for?
How do you get code from chemicals? How do you stir ocean water and get digital code? Nobody knows. And if you don't have code, you can't have genetics. And if you don't have genetics, you don't have heredity. So, like, if you're going to figure out anything about where life came from, you got to solve this.
Yeah.
And so I figure it's worth $10 million. So we'll pay you $100,000 if you figure out in any way, shape, or form. And if it's patentable, we'll pay for the patents and the attorneys. And when the patents are granted, we'll pay you $10 million and buy the rights from you and partner you into the company. And then we're off to be the next unicorn on, Wall Street. Okay, so, but you don't get to make up a story about a warm pond and a lucky lightning strike and a happy chemical accident. Oh, well, there were these RNA strands and they started replicating and they bumped into some lipids and it turned into a protocell. Okay, like, this is kind of the story they tell you. They're welcome to hypothesize all they want, but that is all that it is. Okay? It doesn't even come close to explaining the real questions that we have. Okay, so this is kind of some background. So about a year ago, one of my friends came to me and he goes, Perry, I think I know where we could get hundreds of millions of dollars for science funding. This is all very tentative, but he goes, do you think you could help me figure out like what a new model for science funding and publishing maybe should look like? And I go, sure. And so I already knew all these scientists, so like my prize, I've got the leading physiologist at Oxford on my judging panel. I have the leading geneticist at Harvard on my judging panel. I got some pretty serious people. And I've become friends with a lot of like really top scientists. And so I started calling up these scientists. I get them on Zoom. I was using Zoom 5 years ago before anybody was talking about Zoom. I'm an early adopter. I get these guys on Zoom and I go, Stu, science publishing, science funding, what are the problems? What's it like? Oh my word. They would just vomit all over me. Oh man, dude, like it is a crap show, man. It is bad. Okay, so how does it work? Well, so like here's one version of it. I talked to a really sharp 30-year-old postdoc. And she goes, Perry, science publishing is like the best racket ever. Because here's how it works. She goes, so Nature magazine, so there's all these journals, but Nature is the #1 journal, at least in biology. And so everybody wants to get published in Nature, and it is harder to get published in Nature than to get into Harvard Law School, okay? It's really hard. And if you get published in Nature, man, you're in. You'll get a job. Your career is off to a good start. Like, all you have to say is, well, take a look at my article in Nature published in 2019, and they'll be like, ooh. She goes, so, you have peer review. And you write an article and you publish it. So the libraries have to pay for the subscription to the journal. It's like, it might be $600 a year for one person, and they have group subscriptions. You have all these institutions paying for that, okay? And then the science research was paid for by public money, but it's not accessible unless you pay the subscription fee. And if you want one article, it's $40. That's pretty standard. And she goes, but get this. You also have to pay the magazine to publish it. So if they accept your article, you're going to pay $3,000 to $8,000 publishing fee. Not only that, the peer reviewers don't get paid. Okay? And the way it works is you can name 5 peer reviewers that you would prefer to have, that they could at least ask, and 3 that you don't want because you think that they would be jealous or not like it or something like that. And she goes, if what you're working on is like new, groundbreaking, doesn't fit the current paradigm, challenges the current paradigm, good luck. So it's the same old guys getting published and cited over and over and over again. It's like a big giant Go Boys Club, and Nature Magazine and Elsevier make tons of money, and they make it at the expense of the universities. And like, we have to play this game, and if you're doing really good, groundbreaking work that challenges the status quo, you end up in a 3rd or 4th rate journal that nobody reads or pays attention to. This sucks. Like, I asked my physiologist friend, Dennis Noble, he's one of my prize judges, I go, so Dennis, on a scale of 1 to 10, how bad is it? He goes, it's a 9. It's horrible. All right. Now I asked another guy, 70-year-old professor. He's published in multiple fields. I said, on a scale of 1 to 10, how bad is it? He said, it depends on what field you're in. If you're in theoretical physics, it's a 3. If you're in chemistry, it's a 3 or a 4. If you're in biology, it's an 8. If you're in cancer, it's an 8. I go, why is it okay in physics and chemistry and bad in biology and cancer? He says, well, I don't know, but I have an idea. We know the foundations of physics and chemistry pretty well. It's not that controversial. The foundations are pretty solid. Because we have no idea what the foundations of biology are, even though people pretend we do. We have no idea what the foundations of cancer are, so it's all a bunch of politics. And if you're not like in the club, it's a big problem. Now, my perspective on this was, now I'm starting to understand. So you remember that whole like evolution is random and accidental story that you always hear? How on earth did that story keep going for like 75 years? It is seriously starting to crumble now. Any serious biologist now doesn't really buy that story anymore. Okay, but the public hasn't got the memo. And even in the journals and mainstream science, that story stuck for a long time. My question was, how is it possible that in an empirical field like science that you would have a story that bad last that long? Well, the answer is systemic. So if peer review is a monopoly, and you only become a peer reviewer if you're in the club, and the only people let in the club are the people that are allowed to be peer reviewed, you have this circular feedback loop, and you have an echo chamber. So echo chambers did not start with Facebook and Twitter. Okay, echo chambers are alive and well in science publishing and everything. And so I was like, well, okay, so whatever we come up with, it needs to not be subject to that problem. And also, there's another ditch that we need to not fall into. If we're going to reinvent science publishing, we can't let what happened to journalism happen to that. because journalism is dead. I mean, okay, there's like 0.4% that's real actual journalism, but most of it's clickbait headlines and nonsense. So we can't let that, that's worse. That's like worse than a tyranny, okay? So we can't have anarchy. So, shift gears slightly, but we're still dealing with the same questions and problems. So, March of this year, coronavirus hits. And now we are literally a week into, you remember how terrified everybody was? Like, what on earth is going to, like, is the whole world going to go to hell in a handbasket or what? So we're like right in the middle of this. This is like the worst part of the pandemic. Nobody has any idea what's going to happen next. And I have this publicist, and she's supposed to be getting me Evolution 2.0 publicity. So we had press releases on PR Newswire, and we got articles in Financial Times and different places. And she's like, Perry, nobody in the media wants to hear about anything but a virus right now. Like anything that's not virus, you're like, surely you have an angle on coronavirus, like an Evolution 2.0 angle. And I thought, well, I should, but I don't know, I haven't come up with one. Well, let me give this another try. I said, all right, it's a Saturday. I'm going to spend all day today working on what's an Evolution 2.0 angle. So what would that mean? Well, so remember I'm talking about the corn plant, and I'm like, the corn plant rewrote its own operating system. How did it do that? Well, we have a little bit of an idea how it does that. It's got all this machinery that rearranges genes and chromosomes. Well, with a virus, viruses do not have that machinery. So how does a virus evolve? So I'm like, all right, it's a Saturday. I got all day. I'm going to spend all day. I'm going to watch YouTube videos. I'm going to read scientific papers. I'm going to email all these scientists that I know. I'm going to try to find something, like there's got to be some missing piece here. So I got this friend named Jean-Claude Perez, and he's in France. He's a retired IBM guy, and he's done a number of papers with Luc Montagnier, who won the Nobel Prize for figuring out HIV. And it was literally 3 or 4 days before this paper got published. He emails me, and he goes, because I asked him a question, he goes, here, read this. And so he sends me this paper that he wrote with Dr. Montagnier, and he says, coronavirus was engineered in the lab and we proved it. I'm like, okay. And he sends me this paper. And I read the paper, and what the paper says is, there are chunks of HIV and SIV inserted into the coronavirus, and like, look, this piece from over here, this piece from over here, and like he's got all the diagrams in there, and I'm like, dang! But wait a minute, like, I need more information. He's like, dude, like this paper's coming out in 3 days and I'm too busy and can't help you. And so I get some other people involved, and we start looking at this, and so I get enough people helping to go, if he's right, this is like a big problem, this is like major headline news, but is he right? And I start reaching out to a bunch of scientists that I know, and I got like shrugs. So like a week goes by, I haven't gotten anywhere. And his paper, what's in his paper is like, that's not good enough that I would sign my name to it. There's too many unanswered questions. So what did I do? How many of you know what Upwork is? Oh, everybody needs to know what Upwork is. Upwork is the site where it used to be called Elance, which I think is a much better name. You can hire any freelancer to do anything you can think of. Like, you want somebody to Photoshop a picture, or you want a computer programmer to write a $100,000 piece of software, or anything in between. Like, you can hire. So, I go in Upwork and I hire 2 geneticists and a virologist out of the Evolution 2.0 funds, and I'm like, you read this paper and you corroborate everything he says, and they bang away at that for about a month, and here's what we came up with. So you know those HIV sequences that are inserted in there? I could find those sequences in your DNA, a goldfish, a sparrow, a protozoan. They're so short. I mean, bad analogy maybe, but it was almost like finding I before E except after C in a book. He didn't prove this. This is not unique enough. And I'm like...
And for it to be unique enough to be able to say, this thing was just engineered in
Yeah.
the lab. We took this, we took that.
Yeah.
And so he had these little things that said, see, it was just manufactured in a lab. And you're saying,
No. And I'm like, well, no, keep in mind, like, while this is going on, I'm like, am I sitting on, like, the world's most explosive news story?
Right. Right.
It's like, well, you better have your story really ironed out before you put that out there. So, it's like, no. And, like, he didn't retract the paper, and he's still out there, but nobody's taking it seriously. So, anyway, but now, I had another question. Because, and here's what it was. So, on the screen here, this is the original SARS from like 17 years ago, right here. This is the diagram of the different segments of the virus. This is the MERS virus, which is Middle Eastern Respiratory Syndrome, which I think like 2009 or something like that, that version was killing some people. And then here's the new version that we're dealing with now, which is why we're all wearing masks. Now, take a look at this. If you just compare these three, what jumps out at you? What do you see? Anybody?
First of all, your thing you said they're a family, right?
Yes. Yes. They're a family.
They're somewhat similar.
Yes.
Some of them look just rearranged in the order.
Yes. So this one has an M, this one has an M, this one doesn't. It's got a 4B and a 4A instead. Right? Well, actually, this M is over here, and there is no 4 over here. These have a 9B, this one doesn't. They're modular. Like Legos. Now, you guys wouldn't know this, but that does not fit the standard story that you get from most virologists about how viruses evolve. Most virologists talk about little copying errors. In fact, this is just like the other evolution conversation. Oh, it's just copying errors in selection. No, something's moving these things around. Here's an even more detailed picture of more versions. This is called an alignment. So they all have a protein called orphan 1. And then you have various, some of them have certain things and some of them don't. But you see how modular this all is? I looked at this and then I start combing through the literature, and I was talking to one of my friends who's done a bunch of evolution work, and I go, Bill, there ought to be a genre of literature about modular virus reconstruction, and I can't find it anywhere. Like, does this even exist? Have they completely ignored this? And he goes, that's a great question. Let me get back to you. And about 3 days later, he comes back to me. He goes, so if you go in this little haystack over here, there's a needle. If you go in this haystack over here, there's a needle. If you go in this haystack over here, there's a needle. Nobody has ever put these together into a coherent story. So my assertion is nobody actually understands how viruses evolve. And that's why we're in a $10 trillion pandemic. So,
Because if we knew how they evolved, we could fix, address, handle.
well, if you know how something works, you got a heck of a lot better chance of stopping it.
Instead of this just whatever, these random
Right.
things that we do.
Right. Okay, if a bomb blew up outside the Hancock building, and everybody said, oh, that was just random. Oh, good job, yeah. Yeah, let's give that detective a raise. Okay, this is what's going on in science, people. So,
Is the reason we don't know the answer to really how it evolved is because the funding for this stuff, Perry, is so screwed up and
Yeah.
we're so far behind in being able to address this thing?
if you're asking a question that's not in vogue or challenges the standard model, then you're threatening somebody's career.
Yeah.
And all of these
Yes.
60-year-old guys aren't going to listen to you.
Got it.
And it's not even because they're bad people.
It's just their people.
Okay, like good people in bad systems do bad things. Yes, sir.
Maybe the silliest thing that you've heard.
Probably not.
But, so you're asking, what's a better model?
Yeah.
Hasn't this been an issue before in a different industry? And I say this working in a company that had this issue and it was disrupted. So I work for Microsoft.
Mm-hmm.
They had a monopoly on operating systems.
Yes, they did.
And
God
so,
bless
huh?
I said God bless them, but
Yeah. It helps me, but the open source community took on this huge behemoth monopoly. You know, it was established kind of thing in the marketplace, and they've built it to a place where even Microsoft has adopted it and has said, no, this holds a lot of value. People in the industry use it because it holds a lot of value and a lot of trust. So why isn't it that you approach this research like an open source community? You have a group of individuals that are trusted, kind of like a consortium. You leave out these magazines and you start publishing these papers to this consortium that people trust. And then they have this feedback into this open source community. And that's where all the trust, the mind share leads. And maybe I'm looking at it as a very simplistic approach, but the similarities are there to where Microsoft was 15, 20 years ago. That's what's going on in my head is it's almost like an open source problem you got.
I think that's an excellent suggestion. In fact, I got a friend named Mark Ingalls who said something like that to me about 9 months ago. And just as kind of a off-the-cuff response to that, I think as long as you have some Linus Torvalds type people who are trusted referees of the process, I totally think that could work. In fact, maybe that's the solution. Maybe it does have to be an open source kind of a thing. Let me keep going with my story, and we'll just keep, because that's not an interruption. This is exactly the kind of feedback I want. So I have a notion of what's going on. So I want you to imagine that there's a campfire tonight, and you're going to drive down there, and you take your guitar, and you're listening to the radio on the way down, and you hear Hey Jude, okay, by the Beatles. And then the next song in the radio is You Can't Always Get What You Want by the Rolling Stones. And so then you get down there, and you're all like singing songs and roasting marshmallows, and you're strumming your guitar, and you go, Hey Jude, you can't always get what you want. And you like make this, you like jam these two songs together, and you mix the lyrics together, and then everybody like is kind of, repeating it and singing it along, and and then the next morning it's like the joke at breakfast. So that's the scenario. So the question is a song a living thing? No. You know what a really similar question is? Is a virus a living thing? Well, technically, a virus, if it's sitting on that table, will sit there forever and do absolutely nothing. Okay? But a virus comes along and touches a cell and sticks and slips inside. Isn't it a lot like when a person hears a song? Like a song changes you. Right? You ever have an earworm? Like you can't get the song out of your head? So there's a symbiotic relationship between songs and humans. And technically, songs are just pieces of paper, they're notes on a paper, they're MP3 files, they're records, they're tapes, they're CDs, they're sounds in the air. But when they get inside your head, they come alive. Now, who made the mashup between Hey Jude and You Can't Always Get What You Want? Who did it? You did. So, my guess, see, the question is, who's doing the heavy lifting here? As far as I can tell, there's only one answer. It's the host. So why does the host want to help SARS turn into Corona-19? There's something going on there. I haven't heard anybody else in science asking this question. So I got a little team and we're asking the question. I got a geneticist. She's working 20 hours a week and she's sequencing all this stuff. And I think we're headed towards an answer. All right, so if that didn't give you enough to think about, here I got something else for you. Last November, I got this email from James Shapiro. He's a friend of mine. He is a geneticist at the University of Chicago. He was one of Barbara McClintock's proteges. Mr. Shapiro is the guy who discovered that bacteria can rearrange their own DNA. He figured that out in 1968. He's 75 now. And he goes, Perry, let me introduce you to Frank and Henry. Frank's the CEO of Bruker Corporation, and Henry's an oncologist. He's a science cancer researcher in Detroit. The three of us would like to team up with you and put together a cancer evolution conference. Would you like to help us with that? And I said, in a hot second, absolutely. I'm in. And so we have organized this conference. It was going to be in Cambridge, Massachusetts, but coronavirus screwed all that up, so it's on Zoom instead. October 14 to 16, so it's coming up in 2 weeks. Now, what does cancer have to do with evolution? Well, that is a really interesting question. I have a friend named Michael Levin at Tufts University. You'll see his picture in a little bit. He says, the question is not why do we have cancer? That's obvious. He goes, the real question is, why isn't cancer the only thing anything ever has? In other words, your body is this finely orchestrated symphony of circulatory system and breathing and nerves and brains and organs and endocrine and like all of these things, and they just seamlessly do their job. Why does that happen? Why do 10 trillion cells cooperate to such an incredible degree? And then cancer is when they decide to not cooperate. So here's a way of thinking about cancer. Cancer looks like it is an ancient response to stress where the cell reboots and wakes up in Windows safe mode. I'm sure at least this guy knows what Windows, y'all know what Windows safe mode is?
Yeah, we know.
Okay? And it's like, hey, I'm protecting myself. I don't know what's going on here. I don't trust all you guys. Who are all you blood cells, and who are all you lymphocytes, and who are all you liver cells? What are you guys doing around here anyway? He's like, you know what? I'm just going to take charge of my own little department over here. And then the body starts attacking it, and then it switches on its evolutionary toolbox. Because every cell in existence has one. Barbara McClintock discovered it in 1944. Cells have the ability to cut, splice, rearrange, and exchange DNA with other cells and reprogram themselves. So now you got a cancer cell, and it's like, it's rebooted in this primitive mode, and its response to everything you try to do to it is to evolve a response that will defeat the enemy. And now you have cells that are in a war with you. Then you hammer it with chemo, and what you do is you kill 98% of the cancer cells. But the 2% you don't kill evolve from one species to 1,000 species, and now you've got 1,000 flavors of enemy instead of one, and nobody can ever kill that. Now, this woman right here, Azra Raza. Let me tell you a little bit about her story. Azra is an oncologist at Columbia. She is highly published, highly celebrated, highly respected. This book came out a year ago, The First Cell. The title of the book refers to the first cancer cell in a cancer case. Like, what's the first one? Her husband was an oncologist. He died of cancer. Okay? Sad, tragic. Life goes on. A few years ago, her daughter's best friend, 20 years old, I think he fainted or something. And they rush him to the ER, and they look in and give him all this scans and stuff. They try to operate on him, and then he wakes up, and they go, you have the most aggressive form of brain cancer that we know of. There's nothing we can do about it, so we send you back up. And I'm really sorry, but like not a good day for you. And he's like, oh, that's no big deal. I'll just talk to Azra about it. So he goes and talks to his best friend's mom. He's like, hey, what can you do? He was dead 16 months later. And this threw her in a crisis. She's like, I've been treating cancer patients for 30 years and I can solve this. And you know what? We've spent $250 billion on cancer in the last 40 years. And if you have stage 3 or stage 4, you are no better today than you were in 1930. And we're doing victory laps every time we come up with something that keeps cancer patients alive 2 weeks longer than what they had before. And companies are making $1 billion. Like, we are not winning this war on cancer. And she wrote this book. It's a very empathetic book. The stories in this book will make you weep. But it's also a scientific book, so it's got scientific details. You very rarely have those two things together. And in this book, she calls out the elephant in the room. She's like, we are not solving this. We're pretending we are, and we're not. And I interviewed her on a podcast about 6 months ago, and I go, so what was the response of your industry to this? And she goes, they couldn't argue with the thing I said. And I have too much credibility to take down. So they had to agree. Like, wow, you called out the elephant in the room and you didn't get cement shoes? Like, that's pretty good. This guy, Michael Levin, mentioned him earlier. He's at Tufts University. He does a lot of crazy stuff, really interesting stuff. So he's the guy that said, the question is why we have cancer. The question is, why isn't cancer the only thing that cells ever do? Why isn't all life on Earth just every man for himself? Why are cells so cooperative? Well, he's done some really interesting stuff. So one thing that he's done is he can scrape skin and muscle cells off of tadpoles, stick them together, subject them to bioelectric fields, and they will reconfigure and reorient into autonomous creatures. Within a few hours, they grow little, they call them cilia, but basically like little swim apparatus, and they start swimming around. And they're not tadpoles anymore. And to some extent, they can be programmed to do things. And they have tadpole DNA, but they don't act like tadpoles. They're like some new creature. Another thing he's discovered is by playing with bioelectric fields, he can induce cancer in a tadpole and then change the bioelectric fields and get the cancer cells to revert back to normal cells. He says cancer is a disease of identity. It's that the body has lost the ability to communicate to those cells that, hey, you're part of our team, and you're supposed to be doing this stuff. And they differentiate it. It's like schizophrenia. They think they're somebody else. By the way, how many of you have had like a tragic, lost a family member to cancer story? Yeah, me too. My dad died of cancer when I was 17. So, I mean, it almost goes without saying, right? I don't think we have to get into a big, sad story. We all deal with it. You know, so we've got this cancer conference going on. The thesis of the cancer conference is you can't understand cancer unless you understand evolution, and you can't understand evolution unless you understand cancer, because they're actually the same thing. Now, that's not a conventional view. The conventional view is they got nothing to do with each other. Or the conventional view is, oh, cancer is just some random accidental copying errors. No, it's way more sophisticated than that. And so I have started having all kinds of conversations with people about the cancer business and cancer treatments and cancer research and all this. So there's some problems in cancer research. Here's one of them. So how many of you, in any way, shape, or form, part of your work involves running proper scientific A/B tests of this or that? Okay, so like in marketing, it could be this Facebook ad versus that Facebook ad. Or in manufacturing, it could be this way to build the speaker or that way to build the speaker. This adhesive versus that adhesive. Or this software build versus that software build. Which one crashes? How many of you do something like that in your work or in your school or your lab? Some of you, okay? So, in cancer research, a proper clinical trial of a drug with placebos and blind and A and B and all of the measurements costs $100 million. Now, how many drugs have even a chance of making $100 million? Not many. Okay, so if you don't have $100 million, you're not even a player. Okay, so the drug industry is basically regulated by ex-drug company employees that now work for the government. I mean, this should be illegal, but it's rampant. Okay, and they all exist like to keep competitors out.
And they don't want to cure stuff because the money is in just treating chronic things all the time, right?
There's way more money in chronic illness than there is in curing it.
Way more.
You don't even need a conspiracy. All you need is quarterly profits and a whole bunch of people trying to make the profits.
Yeah, put food on the table and they call it a day. Yeah.
They're not bad people.
No, they're just people.
Although I've had people tell me, Perry, I've seen some pretty dark things in the cancer business. I've seen early detection companies getting bought out by chemotherapy companies so that the early detection stuff won't see the light of day, because if I detect your cancer 5 years before you have it, I'm not going to sell you $60,000 chemotherapy in 2025.
Right.
This is a real problem. Okay, and if all the cancer and science journals are in the same pocket as everybody else,
we're not going to get really cool things.
no. And so I've been grinding away on this question, like, what kind of a funding model would bypass all of this? Then you have the problem of, let's say we have something that honestly cures cancer 2/3 of the time, and it only costs $6,000. Well, if the hospital makes $60,000 on chemo, how are you going to get the hospitals to use it? Like, isn't somebody going to come up with an excuse for why this isn't proven enough or safe enough or whatever? And then you also have the problem of how long it takes for approvals to happen. So, you know, Greg's, are you an angel? You're not a VC, you're more like an angel, or are you a VC some of the time? Whatever,
Yeah.
okay? If you're an angel or a VC, you usually want your money back in like 2, 3, 4, 5 years. You don't usually want to tie it up for 17 years. Like, I don't know, Greg, what, 61, did you say?
Yeah, I am.
Hey, Greg, I got this project. You get your money back in 2037. What do you think about that?
Cool. Yeah.
Right?
Yeah.
Okay, so what do we do about this? Now, one idea that came up the other day with some of my colleagues was, well, what if we ask for donations from people who already give money to this stuff, but then we tell them, look, if you give to this research project, any research that comes out of it, like any commercial developments that come out of it, you get first right of refusal to invest in the commercialization. That's an idea on the table.
So I have a question on that.
Yeah, fire away.
So in terms of research, whether it's medicine versus cancer, diabetes, whatever, typically it is American companies that are funding that, correct? So is there not a thought around how we can create a larger global scale way to actually fund these types of projects that ultimately do benefit the world once we remove the patent off of that branded drug into a generic or what have you, to be able to actually build a more cohesive approach to medicine than basically, and maybe I might be wrong, but the American population funding that type of research.
Anybody have anything to add or comment on that comment?
I don't think the first statement that he made is true. I mean, I'm pretty sure Germany doctors and people and ecosystem is spending as much money as we are. I'm pretty sure France is doing the same thing, the UK, all those countries. So, I think that's already happening in some form. Maybe not as cohesive, but the research is happening all over the world.
The research is, but it's the actual approval of drugs. And again, I don't have the numbers to, I guess it's slightly a premonition or just an anecdotal comment, but it just seems like when we look across healthcare from American to socialism or whatever you want to call it throughout a lot of the European countries, a lot of that comes from the US. It comes from Pfizer, it comes from Lilly, it comes from Hologic. And, if we can get a more cohesive or global approach to solving these issues, and I know there is to some degree, but is there really that much financial backing that's going to allow it to happen?
I don't know specifically in cancer. Generally, I find that science is a very, very international enterprise. And, like our science conference, we got quite a few people from Europe. I don't know if we have any from Asia, but we got people from Oxford, we got people from Germany. If you go to cancerrevolution.org, you'll see. But I also think the bureaucracy is international. I don't know how to propel your question forward other than just what I've said.
No, that's fine. I guess I just personally feel like Americans bear a lot of the research and the funding of types of drugs, and whether that is like I said, an anecdotal comment or not, it does seem like, when I pay $350 for a month of drugs when I don't have insurance versus 3 months of drugs for $15 because I have insurance, there's got to be a broken system in there. And I don't know if it's still a branded drug or whatnot, but somebody has to pay those research costs. And I guess I intrinsically feel it is the American population that does pay a lot of that.
So, reactions, other questions, ideas, alternative funding models. Yes, over here.
I think let Reed go first. Reed, go ahead.
Thanks, Brian. I would just John's comment really quick. I would say there's a lot of regulatory scrutiny in the U.S. and that's part of the reason why you see what you see. In addition to that, so the company that I work for does a lot of global investments, and from the competition that I see, a lot of the drugs actually get started. The research is done in Europe because they have less stringent restrictions in terms of what they can and can't pass, and they have a little bit more flexibility. And I don't know why the liability over there and how that structure works from a healthcare provider, but in the U.S. specifically, we have a harder time bringing a lot of the phase 2, phase 3 drugs in just because of the FDIC and everything that's going on. Sorry, my dog's growling at me. So that's just a little bit of perspective from, I would think, say the cost side. We're always kind of later to the game.
But it just does seem to be that, because I'm not a big fan of big government, but if there is a case for the government to fund stuff, it's this because the profit motive has just screwed things up so much, right? The cure thing. But the process for government funding to get approved is just upside down and so screwed up. So it just seems like some sort of step back. There's a design thinking way, maybe there's some cool way to step back and think about how to actually do this given the problem statements. It is shocking to believe that since we were little, remember the Cancer Society? I mean, I'm old, so I remember when I was a kid, it was always, let's have money for research in cancer. 50 years and we still stink at it.
Yeah.
Right.
I always hear my friends from the right talking about regulatory predicaments, but sometimes I feel like just the political system that we live in, the lobbying, right? You just talk about chemotherapy, people, that crazy example or that no very malicious example of a chemotherapy company buying early testing people. So, I mean, just multiply that by 100 and that's the lobbying system in Washington.
Oh,
Yeah.
it's shocking.
Brian.
I was just going to ask on the topic of funding and also places with zero profit. I've heard of a replication crisis in science, and that's certainly, you're not going to get, no one's going to buy that because there's no money in that. So how does that get, is that something that you think about of trying to reshape this?
Well, I certainly have thought about it. One of the reasons, nobody is going to get a prestigious professorship for replicating somebody else's work. There's no prestige in that. And I have to wonder, well, what if there was just good money in it, and it paid enough money that you could go do your side project?
Yeah.
And do the interesting stuff. Okay, it's boring to replicate somebody else's experiment, but here, it pays twice as well as the regular work, so you could spend 40% of your time on your pet project. I also because I'm an entrepreneur, I think these fields need a huge injection of entrepreneurial thinking. And one of the characteristics of entrepreneurial thinking is skin in the game and risk taking. Entrepreneurs have to make their own breaks and make their own money.
Yes.
And it's well, what if part of a scientist's education, and I don't mean institutionally, I mean you'd have to decide, if you're going into science, if you're going to get your PhD, it's okay, I'm working on my PhD, but I'm also figuring out ways to be self-sustaining instead of just nursing at the same breast that everybody else is nursing at.
There was so much packed in to this hour. As assignment, because I like to not do assignments, I'm suggesting you go back and listen to this again and maybe a third time. Because you'll see, isn't this just, and then you start to take a look at Perry's drawings and you start to get a little bit better sense of why is this virus thing so screwed up with as much money as we have? We had the full force of the federal government for months, totally focused, and 350 million people yeah, let's get this figured out. We really don't know how viruses work.
I have a story for you.
Yeah.
This morning, 9:45, I had a consultation with a company in the UK. They have a camera that you can attach to any smartphone. It's basically a microscope.
Yes.
So I prick your finger, I draw a drop of blood, I put it on a diabetic strip. I run it through the camera, upload it to the server. It recognizes patterns in the blood particular to COVID-19 and is 98.7% accurate. And the biggest challenge they're trying to figure out is how do I get it approved?
Yeah.
It's cheap to make. It doesn't require any reagents, which are chemicals that are difficult to manufacture.
Right. But they would kind of make me nauseous to
maybe.
Drop them.
You'd have to look away and Nora would do it for you.
Yeah, there we go.
Right?
There we go.
And so the biggest
Amazing.
challenge is going to be government regulation.
Amazing.
I said, So could you put a tent in front of a soccer stadium and like the kids can go in if they take the test? Maybe
Yeah.
we could do that, but it would be illegal.
Because it's just not approved.
Right.
Right. So that's my advice, but very Marshall, everybody. Thank you.
Thank you. Until next time, this is the Evolution 2.0 podcast, bridging science, technology, business, and the big questions. To ensure you never miss an episode, subscribe on iTunes or on your preferred player. If you like the show, rate us on iTunes. Join our email list and social media at cosmicfingerprints.com. Until next time, this is the Evolution 2.0 podcast, bridging science, technology, business, and the big questions. To ensure you never miss an episode, subscribe on iTunes or on your preferred player. If you like the show, rate us on iTunes. Join our email list and social media at cosmicfingerprints.com.